Assalamu alaikum wa rahmatullahi ta'ala wa barakatuh. Um, my name is Muhammad G.S. Al-Masharawi. Today I'm going to present with my teammates our Psda project. The title of the project is Analysis of Income and Expenses of Software Developers Across Various USA Cities. Okay, I want to just present my friends, Hassan Ammar, Tanjim Saad, and Saqr Maruf. In the beginning, I'm gonna just give a small introduction for our topic. Our topic is talking about software developers in USA cities, how much they get income from their course or their major, and what they face in paying their expenses and their rents. In general, it talks about their salaries and what they should pay for their life. In this project, we used some utilizing tools such as Excel sheet and R programming. For the Excel sheet, we got the Excel sheet data from, now this is about the data set also. For the data set, we got an Excel sheet from the website called Kaggle, which is a website gives you some data resources and some researches, which is authorized also. So we can say that all our data are authorized. So the total records we used for this project and we will present today are 77 records. Today, inshallah ta'ala, we'll be going through the tests that we made and we will show the records, what happened through the records and the calculations. First of all, I'm going to talk about the data analysis. In the data analysis, we made the hypothesis test. Okay, let's go through the hypothesis test. What's the hypothesis test in our project? First of all, we got the average or the mean income for the software developers in USA cities and states, which is $111,845. And also, we made one sample hypothesis test. We aim for 95% confidence level, which is alpha is equal to 0.05. In the beginning, we made the statements. The null statement, which is the basic statement, mu is equal to 111,845, which is the mean income for our software developers. We got it from Google, and we're aiming in our hypothesis test to get a mu greater than the null hypothesis that we made, which is the alternative statement. H1 mu is greater than $111,845. Now I'm gonna explain some variables. I'm gonna give a brief meaning for our variables. For example, the mean sample, it's the sample mean of the price. The SD sample is the standard deviation of price in sample. The size is equal to size of sample, and Z value is the test statistics. Now I'm gonna give just a brief conclusion about I'm just gonna give a brief conclusion about our hypothesis test. As we can see here, the test statistics that we got from the R programming is smaller than the critical value. Z value, which is 0.906, is less than critical value, which is 1.645. So we can say that we failed to reject the null hypothesis, which is H0. And this is also sufficient evidence for us to conclude that the sample average salaries for software developers in our research is smaller than the sample of the average salaries Google reported. Now, this is my part for the hypothesis test. Now I'm gonna go to the next part. My friend's going to the next part, which is the correlation test, which is my friend Tanjim Saad.
Okay, thank you, Muhammad, for handing me over the floor. Now, ladies and gentlemen, I will explain for you the correlation test. So for here in our project, we have done the correlation project for the mean developer salary and the rent average value, which are the two variables we get from our Excel sheet. So for the correlation test, at first we should look at the scattered plot. So here we can see that in the scattered plot there is a very little weak positive relation between these two values. So for this one, for the correlation test, we have to find the critical value, degree of freedom, and the p-value. Then we can come to a conclusion. So now I will take you through one by one. So at first, by the test statistics, we can get by doing the test statistics, we get the value of t here is 0.440, and also the degree of freedom is 75, and the correlation coefficient is 0.051. So as we know that 0.051 one is close to 0.05, so we can conclude that there is a weak positive correlation between these two data. Now if I talk about the hypothesis, so let's take the hypothesis as P equal to 0 as the null hypothesis, and P is not equal to 0 as the H1. So P is not equals to 0 means there is linear correlation, and P is equal to 0 means there is no linear correlation. So after doing the analysis, we can and find that t is equal to 0.442. So if we go to the conclusion of our correlation test, so as the t is equal to 0.442, which is less than 1.97. So here we fail to reject H0, which is null hypothesis. So we can conclude that there is no statistically important correlation between the mean developer salary and average value given on the data set, which which means any observed relationship in the scattered plot may be due to the random change rather than a correlation. So with this, I'm concluding my part. Now I'm handing over the floor to our friend Hassan. He will explain the ANOVA test and regression test. Thank you.
Thank you, Jim, for handing me the flow and for explaining the correlation. So I'm going to explain briefly about our regression test first. So in our regression analysis, we actually undertook an assessment to ascertain the presence of a linear regression between the mean developer salary and the rent average value. So actually, the rent average value is serving as the independent variable which we are going to use to explain the variations in the dependent variable, which is the obviously the mean developer salary. So here is our data representation or the output that we got from our programming. It actually shows the median, the 3Q, and the max, and all these information as shown in the photo. And for the hypothesis, actually, we have two hypotheses. First one is that there is no significant linear relationship between the mean software developer salary and the rent average, which is what when beta 1 is equal to 0. And there is a significant linear relationship between the software developer salary and the rent average when beta 1 is not equal to 0. So for our analysis, we use these formulas as shown here, which is rent average, intercept, and the slope, and r squared f statistic. So the actually the positive slope is giving an indicator that higher software developer salaries are also linked or associated with higher average rents. So the high r squared value suggests a strong relationship between these two variables. So for the conclusion, I can conclude that the analysis of software developer salaries and average rent in various US cities, it's actually showing a clear and significant links that as long as salaries are going up, so do rents and living expenses are. So this relationship is actually strong, and the model is explaining nearly 78.9% of the difference in rent prices. So high F statistic and very low p-value is indicating that the model is statistically sound. And in practical terms, we can say that cities with higher paying tech jobs are actually tending to be also expensive to live. So that's an important piece of information for software developers or people in the tech industry who are thinking to go to cities with high paying jobs. So I'm going to move on for the ANOVA test. So here's the ANOVA test for the relation between mean salary and housing. So we have got the plotted graph by using R programming, which is shown in this photo. Uh, and then for the hypothesis, The null hypothesis is stating that there is no significant difference between the group means, meaning any difference is due to chance. And for alternative hypothesis, stating that there is a significant difference between at least one pair of group means. So residual just fit the plot. So when the red line is flat and residuals are scattered evenly, this is suggesting linearity and equal variance. So our plot is showing curvature and spread, which is indicating potential nonlinearity and unequal variances. And for the QQ plot, if points follow the diagonal line, residuals are normal and deviations are especially in the tails, which suggests non-normality, and our plot is showing deviations hinting at non-normal residuals. Here's extra plots for the residuals vs the. And for the p-value, it's actually we can see that here we have all the tests, and for the conclusion of the ANOVA diagnostic plots, it's actually revealing several issues with the model. The residuals vs fitted plot shows nonlinearity with a curved red line and the changing spread of residuals. If we look at the p-value, which is 0.2478, it's much larger than 0.05, so we can conclude that there is a significant difference between median home price based on median home salary. And I'm going to pass the conclusion of the whole project to my friend Sakar.
Thank you, Hassan. Thank you, Hassan, for handing me the floor. In this project, we looked into the income and expense of software developers in different cities, more specifically in the USA as a sample. As the field of software development grows rapidly, this topic is important to understand. As my group mate Mohammed said, we used 77 data records that included city names, average software developer salaries, cost of living indices, and average rent. To analyze this data, we applied various tests such as hypothesis test, ANOVA test, regression, and correlation. The tools we used in our project were R programming and Excel. Our findings will help us understand the current salary and expense situation for software developers across different cities in the USA. This will allow us to compare and make better decisions regarding where to work and live based on these factors. Thank you for watching our project video. We hope you give us the full mark, and thank you. That's it. Please, extra marks. Okay, done. Shall I close the video?